Assalamu alaikum wa rahmatullahi wa barakatuh. This is a quick lab in chemistry, chapter 6, section 2, modeling molecules. Now, during the classes, we learn about the Lewis structure. So today, inshallah, together, we're gonna modeling carbon dioxide, which was your homework if you remember. So first of all, we're gonna draw the Lewis structure for the carbon dioxide, and then we're gonna model it. So to model the carbon dioxide, you need those models here. As you can see, it's in your student book as well. We called it the balls and sticks. Now the sticks represent the chemical bond, and the balls, it represent the atoms. And I know sometimes the element could form a single bond, as you can see here, and sometimes they form a double bond. So as you can see here, there's two holes, so you can form two chemical bond from this one here. Now I know maybe this is not going to be available for everyone, so you can still modeling the molecules, but instead of using those models, you can use clay and a toothpick. So I think that is going to be easier. If those things is not available, you can use clay and a toothpick. So before we start, I'm going to tell you about models. It's really a scientific methods, and it's not only in chemistry, it's in all science. We have it usually when we studying something are too big, like the solar system, or we studying things are too small, like cells or atoms. It's really helpful. It helps us to have a fully understanding about the things we learn. And it doesn't have to be a three-dimensional object. It could be a concept. So if you remember in the first term, we learned about Rutherford model about the atom, and Thomson model as well. And those were Thomson idea about the atom and Rutherford's idea about the atom. So it could be conceptual. Okay, so let's start by doing the Lewis structure. Draw Lewis structure for the carbon dioxide. First of all, you need to know the atoms you have here. You know I have a carbon and I have an oxygen. And if you remember the rule, we need to determine the electrons we have. Also, we need to determine the electrons we need. So by electrons we need, we mean the octet rule. Is it follow the octet rule, which means it's gonna be stable by having 8 electrons, or is it if it doesn't follow the octet rule? So that's what we mean by the electrons it needs. So to know the valence electrons, now what electrons you have, we mean the valence electrons. To know the valence electrons, you need to look to the periodic table and see each element in which group. If you look in the periodic table, you're gonna find the carbon in a group 14, which means the valence electrons for the carbon gonna be 4 electrons. If you look to the oxygen in a group 16, which means the oxygen gonna has 6 electrons. Those are the valence electrons for the oxygen. Now, if you look to the carbon follow the octet rule, which means the carbon gonna be stable and very happy if it's gonna got 8 electrons. The same idea with the oxygen follow the octet rule, and the oxygen gonna be really happy and stable if it's getting 8 electrons. Now please, there is very important things before you starting your math. You need to make sure that the number of the atoms here it's matching the number of atoms here. Now I write down my valence electrons and the valence that I need for one carbon, for one atom. And if you look to the molecule here, it has only one atom. But if you look to the oxygen, I have 2 atoms. So you need to watch this one here. So because I have 2 oxygen, I'm gonna here multiply by 2 for the electrons I have, and also I'm gonna multiply by 2 for the electrons I need. Now if you remember the rule says you're gonna subtract the electrons you need from the electrons you have, and then you're gonna divide them by 2, and then you're gonna divide them by 2, and the answer here gonna show you how many chemical bonds in this molecule. So if you look here, 6 times 2, this is gonna be 12 electrons. 12 plus 4, this is gonna be 16. So the total electrons you have, it's 16 electrons. And the total electrons you need, 8 times 2, it's 16. 16 plus 8, it's gonna be 24. So let's come here and do the math. Electrons we need are 24, and the electrons we have, it's 16 electrons. Divide by 2. Here it's gonna give you 8, and here by 2, so that means 4 chemical bonds. I know in the carbon dioxide they're gonna be 4 chemical bonds. So we're gonna start to draw Lewis structure. If you look, I told you during the classes, always the element you have one atom of it, it's gonna be your center. So if you look here, I have 1 carbon, so the carbon gonna be the center, which means the oxygen gonna be in the left and in the right. Also, we said that I'm gonna know how to draw the Lewis structure when each atom gonna satisfy the octet rule. So I know the carbon has a 4 valence electrons, so we're gonna start them. Usually we draw them like this. And if you look to the oxygen, oxygen has 6 valence electrons, so 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5, 6. So by looking to my math, I know they're gonna be a 4 chemical bond. 4 chemical bond, which means the carbon gonna form a 4 chemical bond. This is a 1. This is 1 chemical bond in each one, so it's gonna be 2. So the electrons, the one it was up, I bring it here, and the one it was down, I'm gonna bring it here. So the same idea with the oxygen, the one is gonna be down. You're gonna form another chemical bond, and the one here down, it's gonna get up, and it's gonna form another chemical bond. Now this is my Lewis structure. To make sure that I get the correct one, I'm gonna see if that follow the octet rule or not. So this is the carbon in the middle, okay? Let's see, after sharing the electrons, let's see the carbon, how many valence electrons it's gonna have. 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons, which mean it follow the octet rule. That it's totally correct. Let's see the oxygen here. 1, 2, 3, 4, 5, 6, 7, 8. So this is correct as well. Let's see this one here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, which means it follows the octet rule. So the correct structure is gonna be carbon and double bond with each oxygen. This is gonna be your Lewis structure. Now I already prepared 2 modeling. This is the first one by using those models. As you can see here, the balls represent the atoms. The yellow one represents the oxygen, and the blue one represents the carbon, and the sticks here, it represents the chemical bond. So you have double bond here between the carbon and the oxygen. As I told you, if this is not available, you can use the clay and the toothpick. And as you can see here, the pink one represents the oxygen and the blue one represents the carbon. So you can do this at home. Okay, thank you so much everyone. If you have any question, write down in the comment below. Thank you so much.